Problem number 11. So I know that theta lies in quadrant 1. I know that the sine ratio for angle theta is 1/3. If I want to try to draw the simplest picture that goes with that information, I would make myself a first quadrant angle. So here's angle theta. And then I'll drop a perpendicular to form that right triangle. If the sine ratio is 1/3, the simplest way to reflect that would be 1 for the opposite side and 3 for the hypotenuse. Sine is opposite over hypotenuse. I can find the missing side here using the Pythagorean theorem. I would have x squared plus 1 squared equals 3 squared. X squared plus 1 equals 9. Subtract the 1 from both sides. That gives me x squared equals 8. And when I square root, let's see, x is going to be positive. I'm in the first quadrant. I end up with square root of 8, which simplifies. 8 is 4 times 2, so I can bring out the 1 4 as a 2. And this simplifies to 2 square root of 2. I think I'll add that to my picture. 2 square root of 2 is the length of the missing side. Now that I have that, I can find any trig ratio that I desire. We already knew the sine ratio. I can find all the rest using this picture. Cosecant, of course, is just the reciprocal of the sine ratio, so that would be 3/1, or 3 when I simplify it. Cosine is adjacent over hypotenuse, so it looks like 2 square root of 2 over 3. The secant ratio reciprocates the cosine ratio, so 3 over 2 root 2. In order to simplify that, I'll need to rationalize, so multiply top and bottom by square root of 2. That gives me 3 root 2 up top. Root 2 times root 2 is 2, and then times that other 2 would make 4. Tangent is opposite over adjacent. And once again, I'll need to rationalize. So that comes out to be square root of 2 on the top, and again there's that 4 on the bottom, root 2 over 4. Cotangent beta is the reciprocal of tangent. I could reciprocate the final answer, but it looks like it would be easier if I reciprocate that original version, the 1 over 2 root 2, because when I turn that upside down, it's already simplified. In fact, I don't even need the fraction on that one. It would just be 2 root 2 as the final answer. Once you have the picture, you have the trig ratios. In problem number 12, we are given an angle and we want to find a particular trig ratio for that angle. Well, as long as you can draw a quick picture and you're dealing with a 30, 60, 90 or a 45, 45, 90 triangle, you can do this pretty quickly. In part A, my angle is 3 pi over 4. That's a memorized value. That's 135 degrees. So that's right here in the second quadrant. Here's 3 pi over 4. I need to find some point on the terminal side. So I'll drop my perpendicular. And when I do that, I need to connect to the fact that I'm looking at a 45, 45, 90 triangle. I know that for a couple of reasons. I rotated 135, and that's 45 short of 180. I also know that any time the denominator here is 4, the reference angle is going to be 45 degrees. Let's mark down the simplest picture we can, and that's 1 square root of 2. Just don't forget about positives and negatives. The x here is negative since I'm in the second quadrant. The y is positive, and of course the r is always positive. That's the picture I need in order to write down this particular trig ratio. I'm looking for the secant ratio. Secant is the reciprocal of cosine. So cosine, if I was doing that one, would be adjacent over hypotenuse. All I have to do is turn that thing upside down. So it looks like square root of 2 divided by negative 1. I don't need the 1, so this comes out to just be negative square root of 2. Problem B, my angle is negative 2 pi over 3. 2 pi over 3 is also a memorized value. It's 120 degrees. I'm rotating in a negative direction. So let's see, 90 and then 30 more would make 120. So somewhere over here. There's my angle. I need to find the coordinates of some point on the terminal side. So I'll drop my perpendicular. And what again I need to realize is that I'm dealing with a special triangle here. 120 is 60 degrees short of 180, so my reference angle would be 60. I have a 30, 60, 90 triangle then. And I know how to label the sides. I'll pick the simplest way possible, 1 across the 30, root 3, the 60, and 2 for the hypotenuse. In the third quadrant, my x is negative and my y is negative. With that labeling, I have everything I need. Cotangent is the reciprocal of tangent. Let's see, tangent, I'm using the reference angle here. Tangent would be opposite, the negative root 3, divided by adjacent, the negative 1, which means cotangent is going to be the reciprocal of that. I can see that the negatives are going to cancel out, and so I'll end up here with positive 1 over the square root of 3. When I rationalize the denominator, I end up with square root of 3 over 3 as my final answer.